Good morning. I'm Chitra, Assistant Professor working in Civil Department, Bharat Institute of Higher Education Research. I am going to give a lecture video on the course name Structural Analysis 2 and the course code is U18Pcce601 and the topic I am going to cover is influence line. So first, what is influence line diagram? It's a diagram shows the reaction, shear force and bending moment at each and every section or instant at any distance of the span that you want to find out. So in short, influence line shows the influence or the effects of loads or the reaction of span. Next is influence line are important in designing the beams and trusses used in bridges, crane rails, conveyor belt, floor girders and other structures when load will move along the span. Next, influence line shows where a load will create a maximum effect for any other function studied. Next is bending moment and shear force. So bending moment BM and shear force SF shows a variation of the bending moment and shear force along the structural element. When a load or set of load is applied to the structural element, the point of action of these loads are fixed. So these diagrams are useful to determine the maximum bending moment and shear force developed in the member and locations of the maximum value due to the application of loads. Next, sign conversions, that is positive and negative values. So in sign conversions, positive and negative values on left hand face of the cut member shows the positive value. Next is normal force N that acts to the right and tends to elongate the segment. Next is shear force V acts downwards, that is tends to rotate the segment in clockwise. Next is bending moment M acts the counterclockwise, that is tends to bend the segment concave upward so as to hold the water. Next is positive shear force A, that is denoted by N. So this positive shear force, it is acts away from the member. It is shown in this picture, that is for this segment it acts from the upwards and it is denoted by N. Next is positive shear force. So this positive shear force, it acts downwards or upwards along the surface of the member and it is denoted by V in a arrow shown upward and downward direction. Next is positive bending moment. So positive bending moment is acting clockwise, so with the notation of M. Next is bending moment and shear force diagram. So look at the picture. For this, in this picture, a point load is acting in a structure. So for this, we are drawn a bending moment and shear force diagram. So here the shear force is nothing but whatever load acting to the left of the section or from the left of the upward reaction. So in this picture, so a positive shear force is drawn in the left hand side with a positive of P by 2 and negative shear force is drawn towards the right hand side, that is P by 2. So this is a shear force diagram with a point load P. Next bending moment is drawn. So here bending moment, maximum bending moment is PL by 4, that is acting at the midspan of the member. So this bending moment is shown in this diagram with a triangular load of PL by 4. Next is this is a picture for a bending moment and shear force diagram with the force F is acting with AB distance. So for a simply supported beam, so for this they have drawn a positive and negative shear force. So positive shear force is drawn on the left hand side of the member. Next is negative shear force is drawn in the right hand side, that is negative shear force. So next is zero shear force, that is maximum bending moment is shown at the load point. So this is the shear force diagram. Next is bending moment diagram. So maximum load will be acting at the force point. So where the force is acting F. So in that particular point only we will be getting maximum bending moment diagram. So with the positive sign of it is shown in this diagram. So this is a bending moment and shear force diagram. Next we are going to see bending moment and shear force diagram for a UDL load of W is acting on a member with a distance of L. So for this reaction, LA and LB are shown in this picture. So with the whatever reaction we got, so with the reaction, positive reaction for the shear force is drawn in the left hand side, that is positive shear force, and reaction at B, that is negative shear force, is drawn in the right hand side of the member, and the zero shear force, that is maximum shear force, is also shown in this diagram. So this is a shear force diagram. Next is bending moment diagram. So for UDL load, bending moment diagram will be maximum bending moment will be at the center span of the member. So this is UDL load. So we got a parabola bending moment. So it is also shown in this picture. Next is influence line. When an applied load is not fixed, that is moving. When the influence line is used to determine the impact of the live moving loads at a single point as the load moves across the beam. Next is influence line are very important in designing the structures to resist the live moving loads. So this is a picture of influence line diagram. So for a span AB, so one unit load is acting at a distance of x, and a C point at a C point with a distance of A. So at a C point it is represented with a distance of A, and then from C to B, so total distance is L. From C to B distances, total distance L minus A. So first diagram is influence line diagram for reaction at B. So first we want to find what is the reaction at B. So if we find reaction at B, so that is 1. So what is the reaction acting at B point is 1 unit. So influence line diagram for reaction B is 1. So this is it is drawn in this picture. So here at unit load, what is the reaction means? X divided by L. So total distance at unit load is X. So that is X divided by total distance L. So this is the influence line diagram for reaction B. Next, coming to the influence line diagram for reaction A. So we have to find what is the reaction at A. So if we calculate, means we will be getting reaction at A is 1 unit. So for in this picture, they have drawn influence line diagram for reaction A. So next we come to the unit load point. So if we take the unit load point, so we know what is the reaction at A is 1. So 1 minus what is the total distance at unit load? X by L. So 1 minus X by L. So this is the influence line diagram for reaction A. Next, coming to the C point. So influence line diagram for FC, that is already we know from the previous A and B steps. So influence line diagram for A is A point. So what we got? X by L. So at unit 1 unit we have to show X by L and C point. So C point, at C point we got, that is 1 minus A. What is the total distance at C point? A distance. So 1 minus A by total distance L. So that is in C point we are getting positive shear force and negative shear force. So this positive shear force is drawn upwards, that is 1 minus A by L, and negative shear force, that is minus A by L. It is drawn in this diagram. And then coming to the C. C point is reaction is 0. Next, influence line diagram for moments. So what is the influence line diagram for the moments? Maximum moments. So at unit load. So unit load is X into L minus A divided by L. Whereas C point we got is A into L minus A divided by L. Next, we are going to see definition of an influence line. So influence line represents the variation of reaction, shear moment, or deflection at any specific point in a member as a concentrated load moves over the member. So next, influence line, they provide a systematic procedure for determining how the reaction, shear force, or deflection in a given point of the structure varies as applied load moves on the structures. Next, we are going to see influence line diagram versus bending moment diagram. So what is the difference? So difference between the constructing an influence line and constructing a shear force or bending moment diagram. Next is influence line represents the effect of moving loads only at a specified point on a member. Then bending moment diagram represents the effects of fixed load at all points along the axis of the member. Next is method we are going to see for the influence line diagram. First is taking a moving load of a unit weight. Next, select a point of interest where reaction, shear moment or deflection is required. Next, placing the moving load at various points and using statics principle to find the reaction, shear, moment and deflection at the point of interest. Next, we are going to plot the values of reaction, shear force and deflection over the length of the beam and compute the point under the consideration. Next is methods of producing influence line makes the life easier. For statically determinate structures, you get straight line, although the line slope may change as the load passes over the key points. So this is the influence line diagram where the unit load is acting at a member. So in this picture, support ABC. So in A to C, a unit load is acting with a distance of X, and A to C distance they have taken as L, and C to A they have taken as L minus A. So for this they have drawn influence line diagram for reaction B is at a unit load is X by L, and then influence line diagram for reaction A they have drawn as at a unit load is 1 minus X by L. Next is C, influence line diagram for reaction at C. So they have drawn us at unit load we know X by L. Then at C point they have drawn us positive shear for positive and negative, that is upwards, that is 1 minus A by L, and negatives minus A by L. So next is influence line diagram for bending moment. So they have drawn us at a unit load point is X into L minus A divided by L, and then at C point, that is maximum moment, that is A into L minus A divided by L. So this is the influence line diagram. Next, we are going to see why it is used unit load for influence line. So it makes easy to multiply the weight of anything or any number of things I want. Next, influence line are very popular for studying the impact of moving, that is variable loads on bridges and other structural structures. Then to obtain the shear, reaction, moment or deflection due to any applied load, or multiple the ordinate of influence line diagram by the value of loads. Next is influence line or bending moment diagram or shear force diagram. So influence line represents the effect of moving loads only at the specified point on the member. Next, shear force and bending moment diagram represents the effect of fixed load at all points along the member. Next, we are going to see some procedure for determining the influence line diagram. So there are two methods. One is tabular procedure and another one is influence line equations. So in tabular procedure, determine the influence line. So first we have to place a unit load, a load whose magnitude is equal to 1 at a point X along the member. Next, use the equation of equilibrium to find the value of function, that is reaction, shear or moment at a specified point P due to the concentrated load X. Next is repeat the step 1 and 2 for various values of X for the whole beam. Next, fourth step is plot the value of reaction, shear force, moment for the member. Next, next procedure is influence line equations. So for this procedure, first we have to place a unit load, that is a load whose magnitude is equal to 1 at a point X along the member. Next, second step, we have to use the equilibrium equation to find the value of reaction, shear, moment at a specified point P due to the concentrated load has a function X. Next, we have to plot the values for reaction, shear, moment of the member. Next, this is example 1. For this example 1, construct the influence line for a vertical reaction at A of the member. So in this AB span, at a distance of 10 feet, we have to draw the influence line diagram for reaction at A point. So coming to the solution, see, look at the picture. AY and BY are the shear force acting at A and B point. So here one unit force is acting at a distance from A. So at a distance of X. So for this particular beam, so first is summation of moments at B. So when we are coming to moment at B, that is moment at B is equal to 0. So we have to come from AY. So what is the reaction at A point? That is minus. So minus AY into, so we have to calculate moment at B is equal to 0 means we have to come from A. So moment at A is reaction into distance. So what is the reaction acting at A point? AY. So it is in anti-clockwise direction. So minus AY into what is the total distance? 10. So minus AY into 10 plus what is the force acting in the member? That is 1. So 1 into what is the total distance? 10. So 10 feet minus what is the unit load acting distance in upside is 2.5. So 10 minus 2.5 is 7.5. So what is the moment? 1 into 7 point distance. So equal to 0. So what is the value for AY is AY is equal to, so 7.5 will be going that side. So minus 7.5 divided by 10 is, we got a 0.75. So this is the reaction at AY. Next we are going to find, that is what is the reaction at a distance of 5 feet. So when a unit load is acting at a distance of 5 feet, what is the reaction at A? So summation of moment at B is equal to 0. So we have to come from A. So minus AY into what is the total distance? 10 plus what is the load acting on the structure? 1. So 1 into what is the distance? 1 is acting at a from A point, that is 5, equal to 0. So next AY is equal to, this 5 will be going that side. So minus 5 divided by 10 is 0.5. So next result for this diagram is, so we have to plot the influence line diagram. So that is AY in y-axis and distance in x-axis. So what is the total distance in the beam? It is given as 10 feet. So according to the 10 feet, what is the AY we got from the equation? That is minus AY into total distance is 10 plus 10 minus x distance. At x distance we are going to find. So 10 minus at x distance into what is the force acting on the member? That is 1, equal to 0. So AY is equal to 1 minus 1 by 10x. So this is a reaction we got at for AY. So for reaction at AY, equation is 1 minus 1 by 10 into x. So if we are plotting for in x and AY, so for 0 distance, what is AY? So if you are putting 0, x is equal to 0, so we will be getting AY is equal to 1. Next, if you are putting if you are putting x is equal to 2.5 feet, so what is AY distance? So in this equation, 1 minus 1 by 10 into 2.5. So you will be getting 0.75. Next, when x is equal to 5, substitute x is equal to 5 in this AY equation. So AY is equal to 1 minus 1 by 10 into 5. So you will be getting 0.5. Next, x is equal to 7.5. So if you substitute 7.5 in this equation, AY is equal to 0.25. Next, when x is equal to 10, what is AY? So definitely it will be 0. So 1 minus 1 by 10 into 0. So this is the so for this problem, this is the influence line diagram for the vertical reaction of the beam. So this is a solution when the distance 0, 2.5, 5, 7.5 and 10. This is the reaction at 0 and 0 to 10.5. So this is a reaction calculation for the influence line diagram. Next example is, we have to construct the influence line diagram for vertical reaction at B of the beam. Now we are going to find the vertical reaction at a point B. So in this picture, for a span AB, so it is given for this cantilever type of supports. So one point load is acting from A to B with a unit load of 1 at a distance of x. So the span from A to B is given as 5 meters and B to another point it is given as 5 meters. So we are going to construct the influence line diagram at a vertical reaction B point. So coming to the solution, draw the free body diagram with a reaction AY and B point reaction at by. So for this particular structure, A to B distance 5 meter it is given. So a unit load is acting on the span AB member with a distance of x. So for this type of problem, we are going to find the influence line diagram by. So similarly, like previous problem, we have to find what is by equation. So here we got by equation is 1 by 5 into x. So we are going to draw the influence line diagram for by. So what is the total span it is given in your problem? That is 10. So we have to plot y axis by and x axis distance. So with this distance, we are going to find at a distance of x. So x is equal to, if x is equal to 0, what is reaction by? So 1 by 5 into 0. So we got 0. Next, we want to substitute at distance is 2.5. So if you are substituting distance 2.5, by is equal to 1 by 5 into 2.5. So what is the value? 0.5. Next, when x is equal to 5, what is by? Reaction at by. That is 1 by 5 into 5. So we got by is 1. Next, when x is equal to 7.5, so what is reaction at by? So 1 by 5 into 7.5, we got 1.5. Next is when x is equal to 10, what is by? So by is equal to 1 by 5 into 10. So we got 2. So we have to plot the diagram, that is influence line diagram. When x is equal to 0, what is by? When x is equal to 2.5, what is by? Reaction at B. Next, when x is equal to 5, what is reaction at B? When x is equal to 7.5, what is the by value? Then x is equal to 10, what is reaction at B? So we got 2. So this is the influence line diagram by. So influence line diagram is nothing but we are finding at each and every coordinate of the structure. Each and every point we are finding the reactions for the support. Next, one more example we are going to see. Construct the influence line diagram for a shear at a point of C. So we are going to construct the influence line diagram for a point C. So for the same span of AB 10 feet at a point 2.5 feet. So we are going to find what is the influence line diagram. So coming to the solution, see, look at the pictures. So in this picture, we have calculated what is the reaction at A and reaction at B. So here unit load is acting at a C point. So definitely in the right hand side, reaction at B is 0.25 and reaction at A is 0.75. So it should be total distance is 10 feet. So we are going to find what is 2.5 distance, what is reaction at C. So coming to the solution, we know MC, that is VC reaction, that is at C point, we are going to find what is reaction at C. So summation of Fi is equal to 0, then VC is equal to reaction at C point is minus 0.25. Next, we are going to find at 2.5 distance. Next, so for this 2.5 distance, what is reaction at A is 0.75 and reaction at B is 0.25. Next, coming to VC, that is a unit force is acting at VC point with a moment of MC. So for this, total summation of Fi is equal to 0, then VC reaction is equal to 0.75. Next, we are going to plot the axis. We are going to find the influence line diagram for x-axis x with x distance and VC. We are going to find what is the influence line diagram for VC point. So this is a picture. So here we got the equation for VC is minus 1 by 10 into x. So in this when x is equal to 0, what is reaction at C point? So 0, if you are putting in this equation 1 by 10 of 0 is 0. Next, at x is equal to 2.5, what is BC we got? That is minus 0.25. So it is in negative. So we have to show the negative side of the representation of the